Assalamu alaikum everyone. Welcome to week 7 lecture 19 for CS116 object oriented programming. Okay, these are the topics that we covered last week. We saw how we can implement operator overloading in Python. It's a kind of polymorphism. Then we learned how we can write our own decorators or how we can use a built-in decorator. We'll be using a lot of decorators in today's session as well. So it will serve as a prereq for today's lecture. And then we saw what are static and class methods. The main topic that we are going to discuss today is abstract classes. We'll see what are abstract classes, how can you develop an abstract class in your program. So this is the only topic which is left from polymorphism. Apart from this, we'll talk about some other concepts also, which are more Python related rather than object oriented programming. Property function or properties, how to define properties, and duck typing. So let's begin. First of all, let's recap what we studied about abstract classes in lecture 3 during week 1. Abstract classes, actually we can have abstract methods and we can have abstract classes as well. So an abstract method is a method which is defined in a class, but it does not contain any implementation. You just write that pass statement because you have to provide indented code after it. So you just write that pass statement and you do not provide any other implementation there. And an abstract class is a class which contains such methods, right? What's different about abstract class? That you cannot instantiate any object of an abstract class because it contains methods which do not have any implementation associated to them. So you simply cannot instantiate objects of such classes. And if a class inherits from an abstract class, that class has to implement all those abstract methods. Otherwise, that subclass will itself be an abstract class, right? Okay, this is something new. I don't remember if I discussed this earlier as well, that an abstract class can have abstract methods. That's why it's called an abstract class. But such a class can have some concrete methods also. And by concrete methods, I mean methods that contain implementation, which are not abstract methods, right? So it's not limited to abstract methods only. An abstract class can have both kinds of methods, abstract methods and concrete methods. Now let's recap the concept of interface. We have discussed it briefly in previous lectures also. So an interface is simply a contract between the class and the outside world. It is the set of attributes and methods that you define in a class through which that class can be accessed from the main program or other classes or other objects. So that means it's the way how your class looks to the outside world, right? Let me give you a practical example. We all have television sets in our houses. How you interact with that television? Every television set comes with a remote controller. So that remote controller is the interface for that television set. So you are not concerned with how that remote is communicating signals to your TV or how the internal circuitry of your television is working. You are only concerned with the interface. You should know how to use that interface and you are able to enjoy the transmission that comes on your TV. So the same case is here. Whatever you implement inside your class, you just hide it from the users and you just provide an interface, and through that interface a user can access the functionality of your class. Here's another term, API. API stands for Application Programmers Interface or Application Program Interface. API simply is an abstract interface which an application provides for standardization. Like, for example, I'm writing an application and I want the users of my application. By users, I mean if somebody wants to interact with my application or want to connect his or her own code with my application or want to extend my application, he or she will have to follow that specific interface, will have to provide that interface that I have already planned. Otherwise, it won't work, right? So and we can do this using abstract classes. So what actually does an API? It provides a blueprint for other classes. Like I gave you an example that I want everybody to bring some digital media in class. So I just said that you have to bring some digital media. I'm not forcing that what kind of media you bring. You can bring a tablet or a laptop or a laptop of any brand. So, but you have to bring it. So I'm just deciding on a standard, and everybody can follow that standard his or her own way. So this is one scenario where this is helpful in programming. If you are allowing third parties to use your application or extend your application. For example, I am designing an application for a media player, and anybody can extend my code to to put in support for a new kind of media file. So he or she can do that as long as the interface that I provide, they follow it, so they can use my application or they can extend my application. For like if I want every extender of my application to provide at least one method that converts media file to a specific format, so I'll put that in my abstract interface, and then everyone who wants to interact with my application will have to provide implementation for it if he or she wants to extend my application. Similarly, this is also helpful when we work in large teams. A team leader can set an API and everybody has to follow that. So that helps in work division as well. Now, Python is very well known for its packages and modules, that it has a package or a module for almost everything that you think of. So it has a module for defining abstract classes as well, and this module is called ABC. ABC stands for abstract base class. So whenever we make a abstract class, we call it ABC, abstract base class. And if you want to make such a class, what you have to do, you have to derive, first of all, you need to import this module, and then you inherit your class from this module. I'll show you the syntax shortly. And then you can use this decorator with whichever method you want to make abstract. As I told you that you can have concrete as well as abstract methods in a class, so you'll use this decorator with those methods which you want to convert to abstract form. Here's the simple syntax. First of all, you have to import this module ABC. Here I'm not importing the whole file. I'm just importing these two things, ABC, capital ABC, which is a class, abstract base class from which all abstract classes derive. And this abstract method is a decorator. So decorator function actually. So I'm just importing these two things from that module ABC written with small caps. So first you have to include this statement in your program, and then you can derive your class from this ABC. Now this capital ABC written in brackets is a built-in class which you are importing from that module ABC, right? So you simply, this is first rule. If you want to make your class abstract, you have to inherit from this built-in class ABC. Then if you want to make a method abstract, you just write this @abstract method, and then you can define your method as you feel like, right? So you just add this decorator over that method which you want to make abstract, and you have to derive from this abstract class ABC. Now let me show you a simple example. In this example, I'll show you that this point, that an instance of an abstract class cannot be made. So for this purpose, first of all, I'll have to import these relevant classes and decorators from ABC module. This is my class. I'm calling it polygon, and I'm deriving it from ABC. ABC is a built-in abstract class. Okay. I'm including just one method in this class, and I'm making that method abstract. In order to make it abstract, I have to put this decorator on top, and then I define my method, and this method is number of sides, self-explanatory. It should simply tell about the number of sides of a polygon. So I cannot leave it like this. I don't want to provide implementation, but I cannot leave it like this because Python won't allow me. It will expect some intended code below this. So I'll add this statement pass. So just writing pass will not make it abstract. You have to use that @abstract method decorator to make it an abstract method. Okay, now I derive a class from this class polygon, and this class is called square. And if I want this class to be a concrete class, then I'll have to implement that method number of sites. In fact, I must implement that method number of sites. So I am providing an overriding implementation for this method, and here I'm just printing this simple message because it's a square, it will have 4 sides. Similarly, I derive another class triangle, and here also I override this method. In fact, or you can say I'm providing implementation for that abstract method of class polygon, and it will print a respective message. The first thing that I'm doing in my test code is this. I'm trying to instantiate an object of polygon type. Now we know that polygon is an abstract class because we are following those 2 rules. We are deriving it from ABC and I'm using an abstract method inside. So this statement will give error, right? You can run it and see that it will not happen. It will not let me define an instance of an abstract class. But if I define an instance of square is a concrete class because it is providing a valid implementation for that abstract method. So this is absolutely fine. I can call this method number of sites, and this will print this output. Similarly, I can instantiate an object of triangle type, and I can call this respective function, and it will print this message. Now, in this example, I'll show you that we can add some implementation to that abstract method as well. Now, this is contradictory to what I told you earlier. Like an abstract method does not have any implementation. So many languages implement this. Like they strictly forbid you from implementing an abstract method in abstract class. But Python allows you to do that. So let me show you how or how you can use this. I'm defining the same class and I'm defining the same abstract method, but this time I'm adding a custom statement here. So this method is an abstract method, but it has a statement of its own. If I derive from this class, I must implement this method, number of sites. So I can provide my implementation, or I can call this parent method as well. So we know that super function, I'm using that function to call this parent method, and then I can provide implementation of my own. So you have to provide implementation of it, and it doesn't matter if you in that implementation you are only calling the parents class method. So that is absolutely fine, and then you can add code also. So this implementation will make a square class concrete. Let's run it. I am defining an object of type square, and then I call this method. Now what will happen when I call this method? First, it will call the same method from the parent class. So first, I am a type of polygon should be printed, and after that its own line, I have 4 sides will be printed. I told you that an abstract class can have concrete methods as well as abstract methods. So let me show you that too. So the same class, the same abstract method. And now I am defining another method here, shape. And this is not an abstract method. And how do we know that? Because I'm not putting that @decorator over it. So it's a concrete method. A child class can override it, or it's a choice. Like a child class can override it or cannot override it. Like can just leave it like as it is. But a child class must implement number of sites method. So here's the child class. It's overriding this method number of slides because it has to do this, the same old implementation, and it does not providing any overridden implementation for shape. So, but it is inheriting that method because it is inheriting from polygon. So I define an object. I call this method number of sites. It will produce the output as before. And I can call this shape method also because it's a concrete method in the parent class, and it will print this message. In general, a programmer really needs to define an abstract class of his own. But there are a number of APIs or abstract base classes that exist in a programming language, and a programmer can extend from these classes, or can implement those classes and can provide some implementation, some standard implementation. So let's talk about a very common class that exists in Python, which is an abstract class, and it is called the container class. So all the container type objects, lists, strings, dictionaries, they all derive from this class, and this is an abstract class. Now, what does this class contain? It contains only one abstract method, and that is called contains. This is a dunder method, as you can see from the naming format, and it takes one argument x, and it simply checks if x is part of container. So it returns true if x is in the container, and it returns false otherwise. And the special thing about this dunder method is that it is used to overload the in operator. I hope you can recall that in operator. We have used it many times in manipulating strings and lists. So if you want to implement this operator for your class, you have to extend container class, and you have to provide implementation for this method uh, contains. Or you can even provide implementation without extending from container class. So if you are overriding this dunder, that means you are implementing this in operator for your class. And all the container type classes like list, strings, dictionary, sets, they all derive from this class container. So that's why this in operator is supported in all these types. Now let me show you an interesting example. In this example, I'm defining a class called odd container, and this will serve as a container for all odd integers. So that means I'll be checking for two conditions. Actually, I'll implement this, overload this in operator. So I'll check for two conditions. The value passed to for this in operator, it should be odd and it should be an integer. So let's do it. I have two ways by which I can do it. I can inherit from class int container, and I can implement that method contains, and I can also implement that method contains without inheriting from that class container. So if you want to inherit from that class, you have to include this line, because container class resides in this module collections. So you have to import this module, but I'm not doing this. I'm not deriving from this class. Otherwise, you can simply put the name of that container class in round brackets after this class name or container. Okay, I'm implementing this function contains. It's a dunder which will be called whenever Python encounters this in operator. And this is the condition that I have made. If x is not an integer, first condition will tell me is instance will return true if x is an integer, and by placing not, I mean that x is not an integer. Second condition means if x is not an odd number, because x percent 2 will be 0 if x is even. So that's why I have negated that condition, because x percent 2 is equals to 0 will be false. 0 indicates false, so I have to negate it. And in these two conditions, if any of these two conditions is true, because I'm using OR operator, then I'll return false. Otherwise, I'll return true. And this is a simple implementation for in operator for my class odd container. Now let's run some test code. I am instantiating an object of odd container type, and I'm calling it num. And here I'm using this in operator, one in num. We know that how will this statement decompose? It will decompose into this num. It will call that dunder contains, and this one will be passed as an argument to it. So that means one will replace x. So one meets both the conditions. One is odd and one is an integer. So it should print true. Here it is. Similarly, if I pass it 2, it should print false. And if I pass this number, this is again an odd number and it's an integer too, so it will again print true. Okay, now let me show you one more thing. If I call this isInstance method, isInstance method will check if odd container is an instance of num. So, sorry, if num is an instance of odd container. So this should also return true, because that is actually true. Num was defined as an object of odd container. And I want to check one more method. Now this subclass function is a built-in function like isInstance, and it simply checks if one class is subclass of another class. So here I am checking if my odd container class is a subclass of container. Now you see I did not derive from this class. You see I did not put any round brackets for inheritance after my class name above. So that means I am not directly deriving from this class. But the point here is, first let me show you what the output is. Output is true in this case. It should not be true, because odd container is not a subclass of container, because I did not inherit from it. But this is giving true because my class is behaving like container. Container class had only one method, that is contains, and my class is implementing that method, and it is behaving like any other class which inherits from container, because any class that inherits from container has to implement this method. So I'm implementing this method. That means I'm acting like a class which is actually a subclass of container. This concept in Python is called duck typing. Like, although my class is not actually a container type class, or it's not inheriting from container, but since it is behaving like the container class, this statement returns true, right? Now I'll come back to this topic after a while. First we'll discuss properties, and then I'll discuss this duck typing in detail. So the main point of this application was to show you how you can override this in operator. Sorry, overload this in operator by overriding that contains dunder. Now let's discuss a new feature in Python. By new, I mean we have not talked about it previously. Property function. Now, what is a property? If you recall, a property is an alternate name for an attribute. Like a class can have methods, and it can have attributes, and attributes, they are also called properties. So this property function, it helps us manipulate those properties. Now what you do with a property, or what you do with an attribute, you can set an attribute, you can you can define a getter function for your attribute, which returns to you the value of that attribute, and then there is one more function that I'll introduce. You can delete that attribute. So this that means that you will have to write 2 or 3 different functions to manipulate a property. So this property function will allow you to access all those methods automatically and more easily. So let me show you how. Now what you can do is you can use this property function. Now this property function, it takes 4 arguments or 4 parameters. First 3 parameters, they are accessor functions. By accessor functions, I mean getter function. First argument is the getter function. So you define a getter function in your code, and you just pass the name of your getter function to this function, to this property function as first argument. Second argument is the name of your setter function, which you have already defined in your code, and third argument is the name of your deleter function, which you are using to delete that property. And all these 3 parameters, they are optional. You can pass none in place of any of them. And then fourth argument is a doc string. This doc string will serve as the help statement. It will appear in the help function. You know what doc strings are. And if you're not providing any doc string, it will fetch the doc string of getter method. I'll show this to you shortly. Now what this function will do, it will return, it will take these 4 arguments, and it will return an object, and that object's name will be used as the property name. I think it will be clearer if I show you through example. So let's see the example. Okay, this is last point. The name that you use for that object, or where you keep that return object that's coming back from that property function, that name is used as your property's name. Again, let's see example that will help us understand this more quickly. Here's the syntax. You define a class, and you define all these methods: a setter method, getter method, deleter method, and mind it, you have to define an initiator also, so that that instance variable for which you are defining these setter, getters, and deleters, they are implemented. So you define these methods first, and then you write this statement. Now in this statement you see that green word is the new keyword. Actually it's the name of that function, and it's taking 4 arguments. First argument is the name of your getter function, whatever name you select. Second is the name of your setter function, then deleter, and then docstring. And you can omit any of these parameters and place none instead. That will mean that that particular function is not supported on that property. Now you see, I'm assigning the return value from this function to a property name. That property name, actually this property name will point to an object which is returned by this function property. So that property name will be used as the name of the attribute in future. So wherever you want to reference this property, you will use this name. I'll show you this shortly, but before that, let me show you an alternate way for doing this. Now, there is a smarter way of doing the same thing. There are decorators also available for setting this property function. So what you can do, you define your class, you define your initiator, and then the first method that you will define is your getter method. And with your getter method, you use this decorator add property. So add property, and here is my decorator method. And I can include a docstring, and then I can include a return statement here, right? Or you can include any kind of code that you want to put in here. So this is my getter method, and then I use another decorator with my setter method, and then I use a third decorator with my deleter method, right? So the things that you should note here is that there are 3 decorators that I'm using: at property name dot setter, and at property name dot deleter. Now what you should remember here, that first decorator add property, it should be placed with the getter function. Okay, your getter function should come first, and you should place this decorator with your getter function, and the name of your getter function will serve as the name of your property. So you should be careful with that. You use a name that you intend to use as your property name. This could be different from what you are using for your actual instance. It could be anything. So, and this name is then repeated in the decorators, in the remaining 2 decorators, and in the remaining 2 function names. So the function name for getter, setter, as well as deleter is the same, and that name is the one that you are going to use as your property name. And the same name is used with the deleter and the setter decorator. You see, wherever I have written property name, that means all those values have to be same, and you have to define the getter method first. So let's see an example. Okay, let's see an example. In this example, I'll be using property decorators. We saw on last slide that we have 2 options. Either we can use property function or we can use property decorator. So I'm using just one sample here. The other one, I will not discuss it here in this lecture, but the code for that, like using property function, is there in your code file. So you can just go through it. It's not that difficult. If you find any difficulty, we can discuss that in the live session. But here I'll only discuss definition of property using decorators. So here I am defining a class called pencil, and in this class pencil I am defining I want to define an attribute called color. So for that I'm defining an initiator, and this initiator, it defines this instance attribute color in small caps, and it's an instance attribute because I'm accessing it using that self dot operator. I'm assigning it to C will be passed by the user, and if user doesn't supply anything, color will be set to red. Okay, so there is nothing difficult in this. Now I want to define a property for this attribute color. Now what I want to do, I don't want the outside user to access this directly, to this attribute directly. So what we do, we define setter and getter functions. But the problem in using those setter and getter functions is that you have to call those methods. You cannot directly access that attribute, or you can say that if you are accessing that attribute directly, that is an easier way. So property fulfills both things. It encapsulates your instance attribute. It will not allow the users to access this, It will allow you to implement setters and getters. Then you can put as many checks or other details there as you want. And after doing all that, you will be able to access that property just as an instance attribute from outside. So let's see that. So this is my attribute name color. I'm defining a property. So I'm using this decorator at property. First, I have to define my getter function. So here's my getter function. Now you note the name that I have chosen for my getter function will be the name of the property. Now this is the interface, or this is the name that will be visible to the outside class, or outside class or main program should access this property using this name color. So I'm defining a doc string here, and I'm simply returning that value, small caps color. That what actually a getter does. Similarly, I can define a setter method, but this time I'll use the decorator with my property name, which I have chosen to be color, COLOR in all caps. Dot setter is a keyword and follows my setter function, setter method. Now this setter method again have the same name, and it sets the value and it does nothing else. Otherwise, I could have put some checks also here. And here is the deleter. In deleter, the same format, dot deleter is the keyword, COLOR in all caps is the name of my property. And what I do inside this method, I simply delete this property. Del is an operator, we all know about. Now let's test this property. I'm defining this object A of pencil type. I'm not passing any values, so that means that instance variable color will be set to red. Now here you see I'm calling my property a dot color, and it's like calling a simple attribute from a class. But what will happen here, this a dot color will call my getter function. So whatever is happening inside the getter function will happen here. So it will simply return that color, and that will be printed on a screen. See, so we are accessing the getter function, but it is accessed as if you are accessing the property simply. Similarly, I can do this. If you write this a dot property name is equals to, and you assign some value, then this will automatically call your setter function. So setter function will be called internally, and if you are doing any checks or doing something else, that will happen, and this value will be assigned to your actual attribute, which is a small caps color. So now if you print it, it will print green. Similarly, if you call help on this object A, it will print the name of your property, and it will print the string that I have added in that getter function. So I'm not showing the output for that here. You can simply run it from the file that I have provided, and it will show that to you. Similarly, I can delete this property, and if you use this del operator, this will call my deleter from my class, because you are using this operator on my property, so it will call my deleter function. And now if you try to access this, if you want to print it, then this will cause an error because this property has been deleted. So it's a pretty simple code. You can go through it, and in case of any confusion, we can discuss this in the upcoming live session. The whole point of discussing this property thing with you is to bring you to this point that we can define abstract properties as well. We have already made methods abstract in an abstract class. The same way we can make an attribute abstract too. But for that, we have to convert, or we have to define this property function for that attribute first. So now you know how to do that. The only change that you need to make is this, that you have to replace that at property decorator with this new decorator at abstract property. So let me show you the code. The first thing that you will do, this add abstract property decorator, it is there in the ABC module. So you have to import it first, and then I'm defining the same class, but this time I'm extending it from ABC, abstract base class, in order to make it a abstract class. The remaining code, initiator remains the same, and here is the change. I'm using at abstract property decorator in place of at property decorator. The remaining code remains the same. Right now, I cannot instantiate any object of this class because this is an abstract class, but I can define a child class, extend it from pencil, and there if I want to instantiate object of this class, I must declare that property color like this. And if I don't do this, then that means that that child class is also an abstract class. So now this is fine. Let's run some test code. Okay, in this test code, I'm defining this object A of child class. Then I can access this property as we were doing it before. So I'm not showing you the output because it's not that difficult. Again, you can go see it from that file. Now, as last thing today, we'll see what duck typing is. This concept is basically related to dynamic typing, and we already know this concept, not by name, but we know this. We'll just give it a name today. So we'll discuss this dynamic typing and static typing. Dynamic typing means that you do not have to specify type of an object while writing code, and this is what we do in Python. Whenever you define an object, you simply print it, or you simply start using it. You do not specify its type explicitly. This is what dynamic typing is. And even if you are passing it to any parameter or passing it as parameter to any function or returning from any function, that is also done automatically. Python automatically detects the type of your object. This is dynamic typing. In contrast, static typing means that you have to define type of a variable before using it. So there you define a variable and then you associate an object or a value with it. So a variable has a specific type, and throughout the program you cannot change that type. This is what happens in other languages like C++ and Java. That is called static typing. Now, if I want to define duck typing, this is the statement that will help you understand it. If it looks like a duck, swims like a duck, and quacks like a duck, it's a duck. So basically, it means that it's the appearance that counts. If something looks like a duck, it's a duck for you. You don't go see the DNA of that object to verify that if it's a duck or not. So if it's looking like a duck and it's acting like a duck, it's a duck for you. In Python, we can compare appearances with interfaces. So suppose there are two objects, object 1 and object 2, and they both have same interface. So it doesn't matter to us what's happening at the backend. Their backends might be different, but since their interface is same, they can be used interchangeably in any code. Let me show you an example for this. In this example, I'm going to define some simple classes, very simple classes, and then we'll go to the main code and see how duck typing works. This is my first class called airplane. I'm defining a method called fly, and I simply print this simple statement in it. Then I define another method, set number of passengers. I'm passing a value p to it. This p will be assigned to this instance variable number of passengers. Then I'm defining another class called duck, and I'm defining a method here, fly, and it prints something else. It prints something different from the previous fly method. It prints fly with wings. And then I define another method, swim, and I print a statement here. And then I'm defining a third class, fish. It contains only one method, swim, and it prints a different statement. So see, the main point is that in these three classes, methods with same name exist. So let's see how Python dynamic typing can manipulate this. Now in main code, I define this function moves, and it takes one argument x. X could be any object. Since I am not specifying type, so it could be any object. So how I am using it, I'm calling this method fly on x. So that means x should be an object which contains this method fly. Now if you see the classes on the left hand side, we have got options for x now, because this fly method exists in two classes, in airplane as well as duck. So that means I can pass either of them as x to this function move. So I'm defining these three objects, one of airplane type, other one is of duck type, and third one is of fish type. So all that matters or moves is that the object must have the fly function. That means the interface should be the same. So that means I can call this function with airplane object A, And I can also call this with duck object D. This is duck typing, that it doesn't matter how they are implemented at the back end. You see, these both classes, they are different, they have different purpose, they have different number of methods, and they are printing different outputs. But since the interface is same, they both contain this fly method, they can be used interchangeably. Now if I try to call this method with F, this will give me error, because this class fish, its interface is different from these two. This fish class, it does not contain that method fly. So I hope I'm able to make my point here. Now let's gauge some pros and cons of duck typing. First, let's see the disadvantages. We have discussed that before as well, that since Python does not force you to define type of an object, and it does not raise any error if you change the type of an object within your program. So that is really flexible, and you can write simple codes and achieve a lot of things. But the problem here is that sometimes it can be dangerous too. Like if you are using this duck typing or dynamic typing on purpose and you are very sure about it, that is just fine. But if you are doing that by mistake, like you have mistakenly changed type of an object, or you have mistakenly passed one object in place of another, Python will not raise any syntactic error, but it can result in some logical errors, and it may cause your program to crash. So see, this is a really gross picture, but it explains the concept really well. This is the best I could find. Here you can see that I think that's a nose with two holes, and the person trying to connect that plug, considering it as a socket, because sockets also has two holes. So the interface is same, but the functionality is entirely different. So you have to be the point is that you have to be very sure when you are using an interface. Secondly, sometimes it is inevitable, you have to use abstract based classes to standardize some standards. So there duck typing doesn't work. Otherwise, duck typing can easily replace many of the concepts of object oriented programming, like polymorphism and inheritance, which I'll show you on the next slide. So the pluses are that you can replace polymorphism using it. We know that we do not require method over loading because of dynamic typing, right? We discussed this before as well. So you can just go through this. We can also replace inheritance, or especially multiple inheritance, using duck typing. You can go through this slide, and this is just theoretical, and we can discuss it if you don't get it in the live session, because we are running out of time right now. Here's a quick recap. We discussed how to define abstract classes, and we also saw that we can make abstract methods as well as abstract properties. And then we saw how we can create properties via decorators. And lastly, we discussed the concept of duck typing. Thank you.